Now for the synthesis of aldehydes and ketones, you will see as we are going through, you have done a lot of them before. Let's start from alkenes, okay? And in alkenes, you've done this by taking an alkene and cleaving it with ozone, okay? And so when you take an alkene which is substituted, then you get ketone. If it is not completely substituted, then you get an aldehyde, okay? So that's how it works. Now the ozone, the two reactions that I've given you here, they're both very similar except for the workup reagents. The workup reagents are slightly different. So if you see these two different kind of things going on with ozone, don't be worried, it's just a workup reagent, okay? Your key reagent for carrying out this reaction is ozone, okay? So the reaction will still be the same, which means the products will still be the same. So you get aldehydes and ketones. Here is an example of how this works. So if you have something like this, in which the alkene here is completely not substituted, it's all hydrogens, then you get a ketone over here and formaldehyde, okay, over here. So if there was more carbons here, then you would get a more substituted aldehyde. That's all. So ozonolysis is by using alkynes. The next synthesis is from alkynes, and in alkynes you have two kinds of alkynes, terminal alkyne and internal alkyne. So this example that is given to you here is for terminal alkyne. So if you have a terminal alkyne and you use mercury sulfate along with sulfuric acid, then you end up getting a ketone. Okay, a ketone, which means that your functional group is coming on the internal carbon. If you use borate along with hydrogen peroxide, then you will get an aldehyde, which means now your carbonyl is going on the outer carbon or the terminal carbon. Okay, and so you get two different kinds of products depending on what kind of reagents you use. So mercury sulfate will give you internal groups, whereas hydroboration will give you an aldehyde or a terminal group. This reaction is very similar to what you did back in the alkenes reaction for hydration. If you just use the mercury reagent and treat it with alkene, you will get Markovnikov addition and you get internal alcohol. And if you do a hydroboration of an alkene, of a terminal alkene, then you end up getting alcohol as a primary alcohol, or you would get the anti-Markovnikov product. This is kind of similar to that, okay? So which means that the mercury reagent is still giving you what we call the Markovnikov product, and the hydroboration is giving you the anti-Markovnikov product. So the functional group goes on the carbon with more hydrogen. Okay, that is anti-Markovnikov product. If you have internal alkynes, then you will only get ketones because internal alkynes have no hydrogens on them. So if there is no hydrogens on them, then hydroboration and mercury sulfate will give you the same product, which is a ketone. There is no option for an aldehyde. Aldehydes are also terminal groups, so you can't get aldehydes inside. Okay, you have to have that on the terminal group. Synthesis from benzene, this one is not that far off. We just finished doing this. And so you could use Friedel-Crafts acylation, and this is a synthesis of acetophenone. Okay, to make ketones, you can use any kind of acyl chloride. This one is acetyl chloride, but you can use any kind of acyl chloride to get whatever number of carbons you want over here. The only key thing is that the ketone will be attached to the benzene ring. Okay, that's what's going to happen. That's the only kind of ketone you can make from Friedel-Crafts acylation, but that is a synthesis of ketones. To make aldehydes, so for example, to make benzaldehyde, we use what is called the Gatto-Mancotte synthesis, and the Gatto-Mancotte synthesis involves the same kind of a thing, okay, which means you still have an acyl chloride, except that acyl chloride that you're generating is coming from carbon monoxide and HCl. Okay, so you end up getting something like HOCl, all right, except that you don't write it like that because it's generated in situ. In situ means within the reaction. So within the reaction, you generate the HOCl, the chloride, the acyl chloride by using carbon monoxide and hydrochloric acid. So, and then of course you have to use the catalyst, okay, in both cases. But anyhow, so you can make benzaldehyde using the Gatto-Mancotte synthesis. I would prefer it if you remember these reagents. Okay, that would be much nicer than remembering it as HCOCl or HCOCl. You know, it's just not a good practice. Okay, it's good to know what you're really getting your reactant from. So this is it as far as the synthesis of aldehydes and ketones are concerned. You only have two new syntheses to work with. Otherwise, all the other syntheses are old for you. Alkenes, alkynes, benzene, and oxidation of alcohols. These were kind of a review. So these two here then are the new synthesis for you. Grignard's and reduction of acyl chlorides and esters.